Okay, we've been asked to put this video together for various people so they could see at least a video presentation of a 7 horsepower system, even though it's a total of 14 if you put all those motors, a 5, a 2, and a 5 and a 2, with our large over 1200 amp hour battery bank that's run on 185 amp alternators that can go through inverters that can run up to 8 circuits in this particular place. We also have a wind turbine coming in that is right out there. We're going to be adding solar to this system, and we've separated everything out. So Mr. Cook has been working with me for a long time, and he's going to bring this motor up, this system up on that side to 180 volts, and I'll let Brian explain from there what you're looking at.
Close. 181 volts.
Okay, these are 180. He's got it at 181. These are 180 volt motors. There's the amperage. You want to explain that, Brian?
This is the amperage being consumed. This is the amperage being returned. We've got a loop in it. Being it's a true directional meter, it measures in both directions.
It's also being verified on a second Shark meter. The people at Shark weren't believing of the different readings that we were getting because they're just too overwhelming.
This one is looped. This one is not looped.
This is just reading the 7 horsepower.
And it's reading only what's being consumed.
And it might be a half an amp higher. That's that plus or minus 2% of the meter readings. But it's showing that both of these meters are categorically the same in verifiable knowledge. So we're at 180 volts. What's our RPM on that motor under load? About 2196?
Yep.
Okay. So now at 2196, I'll let Brian explain your wave pattern. Let me get a good close shot of what it is. Explain what they're seeing there, Brian.
That is the primary side, the hot leg, and it's showing that it is a true AC waveform. Shows your maximum and minimum on the voltage peaks. Shows your RMS voltage, which matches what we showed on the Shark machine.
Around 181 volts,
181
right?
volts. Yep. And that's with AC only. It's not showing it have any DC, and we'll go to a DC coupling.
Which adds the DC
and then
in.
if there's any DC in there, it will add it to it, and you'll see it. And there's no DC showing whatsoever. Numbers stayed the same.
Okay.
Now when we go to channel 2, do that again. There. Now that's the negative leg, and it shows our 180 volts RMS. And we'll show that we have a lot more negative voltage than we do positive voltage, which you can see there.
There's your zero line. Okay. Now when you add the two together, what ends up happening there?
Now,
AC and DC.
well, come on. Now when we go to DC coupling, you see the zero line drop, but bring the scale
now
up
look
so
at the
it shows.
voltage.
Now you can see our RMS on our negative leg is 267, 268 volts, but we're only feeding the system 181 volts.
Which is verified right here. 182 volts. But look what we're generating at AC and DC combined. 268 volts, 267 volts. Now, that in of itself is showing a tremendous, so let's go inside and take a look at this is a TED meter that we have. that's reading total consumption on this system, which is also in here on the laptop. And this should be what, around 5,300 watts that system should be consuming?
It should be up there pretty high. It's right now it's showing 1768, but that's RMS. That's what's going in both directions, because this unit doesn't know how to decipher total directional.
So the difference alone is showing a huge reduction in RMS.
Exactly. Yes.
On the efficiency base. Now, what is the shark meter? Can you flip over to that screen? And let's take a look at the shark meter. We got phasers and we got everything. Explain what we're seeing there.
Well, it shows 823 volt amps. Now, that's the watts and VARs aren't going to be 100% accurate because we're looping, so it's only showing you the difference of what's going in and out.
And that's what the 33.64 and the 39.47 is going back out to the panel.
Correct.
But normally this motor pulls between 250 and 300 watts.
Right. And
there's your phasor diagram.
And because it's looped, it's showing both lines. But our primary line that we're starting with is actually got a leading current of 55 degrees.
What's our power factor?
It's not going to show an accurate power factor.
It won't show it on this?
No, because they're looped.
Okay.
Our power factor on those motors runs about normally 57.
And we've gotten it as high as what, 73?
Yeah.
So now we're going to go back out here and we're going to show you when we plug in 6 more motors that are more DC motors into this system, it doesn't increase the consumption.
We're going to turn this down and we'll match the voltage.
Yep, he's going to bring the voltage down to 130 volts now, since these are 130 volt motors. And we're going to run 8 motors, these 8, on this same system over here. And I want you to hear, let's get an RPM on what the motors are running now before you plug it in.
Okay, we're at right on 130 volts.
We're on 130 volts. We can verify it off of this system too. 130 volts. What's the RPM over here now?
We're showing 1789, 1790.
Okay. Now watch this. When he plugs in these 8 motors, you would think that the draw would pull down on the motors and slow it down. Isn't that what you'd think, Brian?
That's what you would think.
He's going to plug it into the same circuit on our electronics. Did you hear it just speed up? Now we're running 8 more motors over there that I'll show you. Now what's the RPMs now, Brian? Went up to 1964. Almost over a 200 RPM or so gain. And then, but yet look at what the total consumed is of running 8 more motors. How many horsepower we got over there?
That's 27 and a half, but they're free spinning. It's still a lot of power.
There's your amperage. Unplug it. Look, 2.3. Plug it in. 3.6. You don't have a whole lot of amperage gain when you plug that in. And yet, what's the DC coupling?
198 volts RMS.
At 130 volts is all we're running. 129 volts. And look at that.
On the negative line, I got 198 volts RMS.
So it's generating that kind of power. Well, that keeps it kind of simple just to show you what we're doing. Let me show you that these motors over here are running. You can hear them. How many horsepower is this, Brian?
27.5.
27.5. These are just treadmill motors that we put in line to show. Well, that's all for now.